So welcome to 4Kids Private Tuition Saga. In this demo lesson, we're going to do some equations involving indices. So you must know your laws of indices in order to solve these equations. So we have an equation here that reads 2 to the power of x is equal to 16. So if the unknown is a power, as in this example, what you need to do is express 16 as a power of base 2. So we need to be creative here. We need to ask ourselves how many times do we need to raise 2 in order to get a 16. So you can try it out by saying 2 times 2, you get a 4 by 2, you get 8 times 2, you get a 16. So I need to multiply 2 4 times, meaning that 2 to the power of 4 will give me a 16. So what I can do is I can rewrite this expression now as 2 to the power of x is equal to 2 to the power of 4, because 2 to the power of 4 is equal to 16. So I can ignore these bases. Once I make them similar, I can ignore them and say therefore x is equal to 4. So that would be my final answer. So we need to make our bases similar. Okay, let's try out another one. This one says here 8 to the power of x is equal to 1 over 64. So we need to see the same base here. There's a fraction, so we can't express 1 as a power of base 8, but we can do so for 64. So let's try to do that and see what we come up with. So if you know your multiplication table, you know that in order for you to get 64, you multiply 8 2 times. So 8 is going to multiply itself 2 times to give you a 64. So this will be 8 raised to the power of 2. When you get to this stage, you need to remember now, we once said that when we have a negative power such as this, I can say a to the power negative b. I can make this power positive by just saying 1 over a to the power of b. So I put a to the power of b under a 1. So what we want to try and do here, in order to have this form, we need to move from this side to this side. This is what we want to try and do with this fraction. Okay, so let's see. So what it means is that if this is a positive power in the denominator, I can rewrite this as 8 to the power of x. Going in reverse with that other law, I end up with 8 to the power of negative 2. So if I put it in the numerator, it becomes a negative. So this is, we now have these expressions looking alike. So we can ignore these bases and say therefore our x is equal to negative 2. So that would be our answer. Okay, so let's move on and see how we can solve others. We have this one that says here 4 to the power of x plus 1 is equal to 32. Okay, so what we need is to express this as a power of what? Base 4. So is that possible? You can try out and say 4 times 4, I have a 16, 16 by 4, I'm already past 32, so I can't do that. So what we have to do is be creative. We need to try and change this base. We need to try and change this base. So what we can do is we can rewrite 4 as 2 to the power of 2. And if you still remember our product rule, we still have our x plus 1 power here is equal to 32. So product rule says that you can say you have to multiply the powers there. So 2 to the power of x plus 1 here is equal to 32. Now we have a new expression when we can try to make this to base 2. So we can try 2 by 2. So 2 by 2, 4 by 2, we have a what? And 8 by 2, we have a 16. So if I redo this 16 by 2, then I have a 32. So 1, 2, 3, 4, 5. So I see that I can raise my 2 to the power of 5. So I can rewrite this expression as 2 to the power of 2x plus 1 here is equal to 2 raised to the power of 5. So once I have that, I can I can cancel out these bases and remain with 2. X plus 1 in bracket is equal to a 5. And now I can solve that equation. Okay, let's rewrite that one. 2x plus 1 is equal to a 5. So this is the equation that we now have. 2 bracket x plus 1 is equal to 5. So it's time to solve this one. So 2 by x, we have 2x. 2 by 1, we have plus 2 is equal to 5. And now we can transpose this to this side. We have a 2x is equal to 5 minus 2. Our 2x therefore is equal to 3, meaning that our 2x over 2 is equal to 3 over 2. So that would be our final answer. X is equal to 3 over 2, which you're not supposed to leave it like this. You're supposed to reduce it to its lowest term. So you can say 2 into 3, you have a 1 and 1 over 2. So that would be your final answer. Okay, 1 and over 2. Okay, so let's proceed and look at other examples. What else do we have? We have this one that reads here 3 to the power of 2 bracket m minus 3 times here my 3. Okay, let me rewrite that. Let me rewrite this one. Let me be more careful here. 2 m minus 3. We need more space here. Okay, times your 3 raised to 5m is equal to 27. Okay, so we need to, so you can see we have base 3 here. So let's try to do this for 27. So 3 by 3 by 3. So 3 raised to the power of 3. 3 by 3, that's a 9. 9 by 3, that's 27. So we can rewrite that as a power of 3. So 3 to the power of 2 bracket m minus 3 times 3 to the power of 5m is equal to 3 raised to the power of 3. So we can ignore these bases once we get to this stage and rewrite this as therefore 2m minus 3. So we are multiplying here, so there's a law. What we have to do is add the powers. Plus 5m is equal to 3. So we now have this equation and we can find our unknown by solving this equation. So let's remove the brackets here. We get a 2m, we get a minus 6 plus 5m is equal to 3. Now what I can do is I can collect like terms. I have a 2m and a 5m. That gives me what? A 7m is equal to, I can transpose this to this side and again I can get here 3 plus my 6, so 7m is equal to 9, and therefore 7m over a 7 is equal to 9 over 7. Cancel out, therefore my m is equal to, so what I can do here is, let's do this so that you can see. So my m is equal to 9 over 7. Okay, let me just try that. M is equal to 9 over 7. So let's simplify this further. 7 into 9 will get a 1, remain a 2 over 7. So that would be my final answer. M is equal to a 1 and 2 over 7. Okay. So I'd like you to proceed doing this, applying these laws. You know, in this, you can do this question. So try to do this one on your own, and I'll meet you in the next video. You can always contact me for online lessons in your mathematics, your combined science, your chemistry. I'm available. So see you in the next video. Enjoy your studies.